This video will cover the sodium borohydride reduction of carbonyls. Sodium borohydride looks like this. It consists of a positive sodium ion and a negative borohydride ion, which is a boron with 4 hydrogens around it. Remember that boron with 4 bonds will have a negative charge. This compound effectively produces a hydride ion as a nucleophile. However, the bond between boron and hydrogen is covalent, and the fact that this bond is covalent makes the hydride ion more nucleophilic and less basic. Let's look at the general reaction for sodium borohydride reducing a carbonyl. Typically, a carbonyl is treated with sodium borohydride in an alcohol solvent. In the first step, the borohydride attacks the carbonyl carbon, forming a tetrahedral intermediate. The tetrahedral intermediate then accepts a proton from the solvent to produce the alcohol. Sodium borohydride reduction of a carbonyl produces an alcohol. Now let's look at some specific examples. Sodium borohydride can be used to reduce an aldehyde. Reduction of an aldehyde with sodium borohydride produces a primary alcohol. Now let's look at the mechanism. In the first step, hydride attacks the carbonyl carbon, producing the tetrahedral intermediate. In the next step, the tetrahedral intermediate is protonated from the solvent alcohol. Sodium borohydride can also be used to reduce a ketone. Sodium borohydride reduction of a ketone produces a secondary alcohol. The mechanism for this transfer is the same.